Hi, this is the notes that we didn't finish yesterday. This is section 1.2. You guys should have copied on the standard form part here already. I was saying right before you guys got dismissed that true standard form, the A value is supposed to be a positive number. It's supposed to be an integer. You know, there's a couple of other rules, but you know what they have here is the common way. A, B, and C, they just got to be real numbers. Real numbers, positives, negatives. You know, A can be 0 as long as both A and B are not 0, like it says here. So just real numbers. That's perfectly fine. So right here, to graph a line from standard form, you find the x and y intercepts. To find the x-intercept, wherever it is on the x-axis, the y value is 0. So you just plug in 0 for y, solve for x. To find the y-intercept, anywhere on the y-axis, the x value is 0. So you plug in 0 for x, solve for y. You're graphing a line. It only takes 2 points for a line. There's your 2 points, x and y intercepts, and you just connect them with a line. So this bottom example here, you got the equation 5x plus 3y equals 15. To find the x-intercept, I'm going to plug in 0 for y. So 5x plus 3 times 0 equals 15. And as you do this 1 or 2 times, you know 3 times 0, it's just going to be 0. You're just left with the x term equals the constant, solve for x. There's your x-intercept. So you go over to the graph, x-intercept 3, you put a point. The y-intercept, plug in 0 for x. Same idea. That x term just goes away. Solving for the y term, or for the y variable, you get y is 5. Go to the y-axis, put a point there at 5. There's your 2 points. If it was a straight line, that would have been a good drawing. But that's okay. There's your line. So sometimes it's easier to graph a line when it's in this standard format. Sometimes it's easier just to throw it into the slope-intercept form. Solve for y, get your mx plus b. It just kind of depends on what equation you're given. All right, so we got 2 different things here. Just some generic information for the horizontal line. When you're watching these videos at home, when you need to copy some stuff down, just hit pause. I'll usually wait a second or two, and then you can copy stuff down, and then you can start paying attention to what I'm saying and what I'm writing. So we got some information about horizontal line. Biggest thing, horizontal lines have a slope of 0. Now, if the slope is 0, you think about the y equals mx plus b, the slope-intercept form, you got 0 times x plus b. Well, whatever x is, 0 times that is just 0. So you got y equals b. This is the equation for a horizontal line. Y equals a number. In this drawing here, this red line is the horizontal. It's crossing the y-axis at 3. So its equation would be y equals 3. For vertical lines, again, you may want to hit pause and copy this stuff down. Big thing here is vertical lines, undefined slope, okay? For vertical lines, you've got the exact same x-coordinate. So when you go to do your slope formula, -2 minus -2 gives you 0. You cannot divide by 0. It doesn't exist. It's undefined. So similar thought processes with the horizontal line. If you try to use the mx plus b form, you have an undefined number times x plus b. You can't multiply anything by something that's undefined. It just doesn't exist. So we can't use that format. Vertical lines, the equation is x equals a number. Now that number happens to be where it's crossing the x-axis, that common x-coordinate. So for this line in the graph, this would have an equation of x equals -2. You can read this question, try to answer them. If you're not sure on the answer, then ask the next day of class, or in this case, you can just ask me. I'm right here. Okay, that's the end of the notes for section 1.2.